Alright, so welcome to projectile motion, where we're going to solve a question based on projectile motion. So the question goes like this. That's saying a basketball player attempts to make a basket from a distance of 8 meters. The basket is 3 meters high, and the ball leaves her hands from a height of 1 meter. If she throws the ball at an angle of 45 degrees, what does the initial velocity of the ball need to be? What does the initial velocity of the ball need to be? So we have to sketch what actually this question is trying to ask us. Okay, so if we check the diagram they're talking about, has to look like this. So clearly you're going to understand it fully to say he had a height. The height at which the ball was thrown was 1 meter. The height at which the ball was thrown was 1 meter. And then the height of the goalpost, or rather the height of the basket, was supposed to be 3 meters. So for you to easily understand, to say what was the height the ball had covered, what was the height of did the ball cover? So what you're going to take, if you cut it here, you do like this. We are going to understand fully to say the height which is going to be here, it is the same height the ball had covered. Now, what are you supposed to do for you to understand to say this is the height the ball had covered? You remember, it will move in x as well as in y. So in the y-axis, I know that the distance from this given point to somewhere here has to be 8 meters. Let me just cut it from here. It has to be 8 meters. It will be the same thing from here up somewhere there, meaning that you take this one to be maybe your horizontal, to say, meaning that the boat to move from here up somewhere there, it had covered a distance in x which is 8, and the distance which is from here up somewhere there, for you to get that distance, the best way of doing this, you can just do it like this. I'll say 3 minus 1, which is going to be equal to what? 2 meters, meaning that in the y-axis the ball had covered 2 meters. So for you to easily understand, to say, these people, they're asking you to say what will be the velocity at which the ball, or what will be the velocity the ball had started with. So we have two different formulas that we can use here. Either you can use trajectory equation, definitely to give you the exact answer, or rather you can use those two simple expressions, like you want to have this one x, which is going to be equal to v initial cos theta t, and also this one, which is y, has to be equal to v initial sine theta, say t, minus 1 over 2 g t squared. So if I use these two, meaning that first of all I need to find the time the ball is going to have for it to move from here up somewhere there. What are you going to use in this moment of time to find the same time? You can use the first expression to find time, because v initial, in short, they want us to have this one, which is v initial. So if you use this one, you're going also to use that one, and you'll be able to find the same thing. And if you use what we call the trajectory equation. Let me try to use a trajectory equation. May I like using trajectory equation to these other methods. So for trajectory equation goes like this. Our trajectory equation has to be, we are saying y has to be equal to x tan theta minus g x square over 2v initial square cos square theta. So like I said the distance which is going to be covered in y at this moment of time, for you to easily find this, you have to do what? It's just a matter of you subtracting, and you'll be able to find this. That's what you're going to put where there is y. And then for you to have x, it has to be 8. The angle is given already, and everything is going to be solved just like that. Okay, so we have 2 here. I'll say this has to be equal to 8, so tan 45, so minus 9.8 multiplied by 8 square over 2 v initial square cos 45. I'll put everything inside the brackets as square like this. Meaning that if you try to punch everything on your calculator, you observe that if I say tan 45, I'm getting 1. 1 multiplied by 8, here I'll get 2, which is going to be equal to 8 minus. If I try to multiply the top part, I'm having 9.8 multiplied by 8 square. We are getting 16. 27.2, say over. Here, whatever you're going to have, you multiply and you'll be able to find that it will give you something down here. So if you say cos, you punch like this, you say open bracket. I'll start with this part, then I will square it. It will be the same thing once you do like what we've been doing in the lessons. So if you say cos 45, I'll say close square. I'm getting this to be my answer, and then I'll say multiply this by 2, and I'm getting 0.7. So meaning that if you multiply everything, we are going to get 0.7 V initial square. You can just take this to the other side, as simple as that. If you take this to this side, you are going to have 2 minus 8, which is going to be negative 6 to 7.2. We divide this by by 0.7 V initial square. So you are going to observe it fully to say here we are going to have negative 6. So just multiply negative 6 by this, say multiply by 0.7 V initial square equal to negative 6 to 7.2. Divide. Okay, so the division has to go like this. You just say negative 6 multiplied by 0.7, even here negative 6 more negative 6 multiplied by 0.7. It's just one and the same thing, even if you use the other method that you can also understand. So if we try to multiply the down part here, you will find that 6 multiplied by 0.7, we are getting 4.2. So meaning that here we are going to have something like this now. I'll have V initial square, which is going to be equal to, so this and that will go. We're going to have 7 here, 2 over 4.2. Okay, now if we continue, just do like this, you square root on both sides, meaning that V initial has to be equal to, so if we try to divide this into, let's say 6 to 7.2, I'll divide this by the answer. I'm getting that. Then I'm saying root of the answer, and the answer has to give us 12.2 meters per second. This becomes the correct answer which these people are looking for. So if you use this other method whereby you find the time, first of all you plug in, still we are going to come back to this same formula. So this is how you have to be handling this question. Thank you very much for watching.